Okay, this is going to be the Advanced Math Unit 3 sample test for 2016. I'm going to try to fly right through this. All these directions for the first ones are f of g of x and then g of f of x. Okay, so when I do f of g of x, I'm going to start with the f function. Okay. Alright, so I'm going to start with the f function, so that's -2, parentheses, plus 1. So the first step is to take that, no x's in that. Then I'm going to put x squared plus 2 inside. Alright, so what I'm going to do, since that's an x, I'm going to go ahead and multiply it. So it's -2x squared minus 4 plus 1. And when I combine like terms, that's -2x squared minus 3. Okay, so that's how you do that first problem. Okay, all right, for g of f of x now, I'm going to start with the g function. The f function is going to go inside of that. Now, when you see squared, what you should do is make a square. All right, so I got -2x plus 1, -2x plus 1. All right, so that's going to be 4x squared. That's going to be -2x, -2x, and 1. Now, when I combine these like terms, because that's an x, I got to include that 2. So what I have is 4x squared minus 4x plus 3 in this case, because 2 and 1 would give me 3. Okay? All right, same thing. I'm going to start with f of g of x. Okay? So I'm going to start with 1/3. I don't know why that's doing that. One-third, parentheses, minus 2. What I'm going to fill in there is 2x plus 3. Okay, so I'm going to distribute that. So 1/3 times 2 would be 2/3 x. 1/3 times 3 would be 1 with a minus 2. So I'm going to have 2/3 x minus 1. Okay, for g of f of x, I'm going to start with g, so that's going to be 2 with a plus 3. And I'm going to fill in the f. So it's 1/3 x minus 2. Multiply that, that's going to be 2/3 x minus 4 plus 3. Combine the -4 and the 3, that gives me -1. Okay? So it's very important, in the first step, all the x's need to be removed. Okay? All the x's need to be removed. Alright, moving on to number 3. Once again, f of g of x. So I'm going to start with parentheses, minus 1. What I'm going to fill in there is x cubed minus 2. Okay? Now, that basically, all I'm going to do is combine my like terms there. So that's going to be x cubed minus 3. Very simple. Now, with g of f of x, all right, the g function, I'm going to put inside this. Now, what cubed means is write it 3 times, all right, with a minus 2. So what I'm going to do is I'm going to do the box first for x minus 1, x minus 1. So I got x squared, -1x, -1x, and 1. Okay, so what that's going to combine to is x squared minus 2x plus 1. All right, and what I'm going to do is I'm going to make one more big box, and I'm going to multiply by x minus 1 one more time. Okay, and after this, now I'll combine this -2 in there. So that's x cubed, -1x squared, -2x squared, positive 2x, positive 1x, and -1. Okay, so the diagonals are going to be like terms. So I'm going to have x cubed minus 3x squared plus 3x, -2, and that would give me a total of -3. And that would be my answer for that. Okay? Now, for 4 and 5, it says evaluate the function. Okay, I think you have the directions on here. All right? Evaluate the function given these terms. Okay? Let's see if I can move this back over. All right, so I got x squared. So f of g of x, I'm going to start with the f function. Okay, let me see if I can shrink this a little bit. Zoom, let's go 75%. No, let's go zoom 100%. There's the problem. Yeah, that's a little bit better. That way I can see it. Okay, so we're going to start with x squared minus 3, okay, because it's f of g, okay? So I'm going to do squared minus 3, okay? What's going to go inside is the next function, which would be x plus 5, okay? Now, since I have this negative 2 here, I don't need to go any further. I can actually use the calculator, okay? So right now, I want to evaluate for negative 2. So I go to this screen, negative 2, arrow, x, execute, and then I'm going to type this in, x plus 5 squared minus 3. And that's just going to give me my answer of 6. Okay? Now this one is g of f. So I'm going to start with the g function. So it's the g function, okay? With the parentheses, I'm going to fill in the f function. Okay? And now I'm going to evaluate for 4. So I'm doing 4, arrow, x, okay, parentheses x squared minus 3, whoops, parentheses x squared minus 3, close the parentheses with a plus 5, and that will give me 18 as an answer, okay? So that's how you do those ones with that, and I think we got 2 more like that. Okay, same thing. Now I'm going to do f of g, so f with a plus 8. I'm filling in the g function. Okay, now what I'm going to do is I'm going to evaluate for 8 in this case. So 8 arrow x. Now it's very important, okay, that you keep your parentheses around that part that's underneath the function. Okay? Because what you want to do, okay, is I'm going 8 arrow x. So then I'm going to do square root. Whoops, square root. I want to tell it, I'm going to keep all that stuff underneath. So 4x minus 4 has got a set, but I also have to put a set outside. So that's going to be 6. Okay. G of f of 1. So I'm going to start with the g function. All right. I'm going to put in the f function. Okay. So I'm going to put in 1 arrow x. Okay, 4, right, 4 parentheses square root. I want to keep x plus 8 underneath the square root, and a parenthesis outside with a minus 4 gives me 8 as well. Okay, and that's that. Okay, this next one says, all right, find the inverse. Actually, this is incorrect. This should be the range of the composition. That's not listed correctly on there. So what we're going to do is we're going to do f of g of x, okay, and then we're going to find the domain and range of that. So with f, I'm going to start with the squared plus 5, okay. I'm going to go ahead and fill in g. Squared, I make a square. So 2x minus 7, 2x minus 7, that's going to be 4x squared minus 14x. That times that's going to give me negative 14x, and then 49, okay? And I'm going to combine with this here. So what I got is 4x squared minus 28x plus 54, okay? So that's going to go in your A part here, all right? 4x squared minus 28x plus 54. Okay? So that goes in there. Then what I want to do is I want to go ahead and graph that. All right? So I'm going to graph it. 4x squared minus 28x plus 54. All right? All right, I'm going to zoom out so I can see it a little bit. Okay? G solve min will tell me that that's going to be 3.5 and 5. I'm going to label this arrow infinity, infinity. This arrow negative infinity, positive infinity, because it's a left arrow going up. Okay, so for the domain, my smallest x value is negative infinity. My biggest is infinity. So my domain is going to be all real numbers. Okay, my range, my smallest y value is 5. And my biggest one is infinity. Since 5 is a point, it's got a line underneath it. So my range would be y is greater than or equal to 5. Okay? All right, so what you're going to want to do is you're going to want to graph those, all right, to take a look at them. All right, number 9. Number 9 is another f of g of x. Okay, all right, so what I got there is I've got square root of, all right, parentheses minus this, so it's going to be 3x. Okay, all right, and that's going to end up being my composition, 3x minus 6. All right, if you want to graph that, all right, that's square root of, I want to keep 3x minus 6 underneath the parentheses. All right, so when I draw it, it looks like that. Okay, now, as you can see, that can be tough to find. All right, I know we haven't done a lot of stuff with this, but the idea is that if I were to take that 3 and go like that, that would give me an anchor point of 2 comma 0. Okay, so when I graph this, you could do it through that, or you could do it through trace. All right, you'll see that if you move over, that's where that point about shows up, 2 comma 0. All right, so this would be 2 comma 0, infinity, infinity. So my smallest x value there is 2. My biggest one is infinity, so my domain is x is greater than or equal to 2. For my range, my smallest y value is 0. My biggest is infinity, so that's why it's y is greater than or equal to 0. Okay? I know that's a little bit tricky with that. All right, now this one, all right, says find a composition that would represent this. Now, it's sort of like working backwards. So the g will be what's in the parentheses. So the g of x is going to be the x minus 3. Now, it's like working backwards. Take out the parentheses and put an x. Well, that's just going to be x. So square root of x. So f of x equals the square root of x. And sort of work through that. If I did f of g of x, I would start with the f function. And what would I fill in? The g function. So it's sort of like working backwards. All right? Okay, so this next one is determine the inverses through composition. So what you're looking for here, if you can do f of g of x, okay? If you can do f of g of x, and that answer gives you x, the answer is yes. Anything else? The answer is no. So when I do f of g of x here, it's 2 parentheses plus 5. I'm going to fill that in. That's x over 2 minus 5. When I multiply, that's going to be 1x minus 10 plus 5, which is 1x minus 5, which my answer now would be no. All right? For this one, when I do f of g of x, okay, let's move it up a little bit. When I do f of g of x there, okay, I'm going to start square root plus 3. I'm going to fill in the g function. If I combine those like terms, I get square root of x squared, which equals x. So that's why that answer is yes. Okay? All right? Now, this next one, find the inverse, then list the domain and range. Don't worry about interval notation. We're just going to continue to list the domain and range, okay, like it's been. All right? Let's see if I can. Sorry about that. Okay, so for the first one, what you have to look at is for a line, you're going to put parentheses around that x. Okay, so what that's going to be is that's going to be x. That minus 1 is located outside, so it's going to go inside and become positive. That 6 is 6 times the outside, so the opposite of that would be divided by the inside. So then what you're going to do is you're going to do 1 divided by 6 for both. All right, that's going to be 1/6. Okay, and then 1 divided by 6 again is 1/6. So what I would have there is my inverse would be 1/6 x plus 1/6. Okay, now what you should do to find the domain and range is go ahead and graph it. Okay, so I got 1/6 x plus 1/6. Okay, all right, so it is a line. All right, infinity, infinity, negative infinity, negative infinity. So when I look at the smallest x value that I see there, it's for the domain is negative infinity, the biggest one is positive, so that's going to be all real numbers for the domain, and then for the range it's going to be the same thing. In fact, every single line you have, where you'll have a line, will be the same thing. Okay? Now, this next one's a little tricky, it's also a line. Alright, so what I want to do is same thing, parentheses around the x. So that's going to be x minus 3, because that's 3 is the outside, it's going to go inside. Now, this is 5 divided by the outside. So I'm going to do times 5 on the inside. We just put the 5x right there. The 8 is the same thing, it's going to be divided by there. So what I got, okay, is 5 divided by 8. Which is 5/8, and negative 3 divided by 8, which is negative 3/8. So I got 5/8 x minus 3/8. Okay, once again, that's going to be a line. Okay, so 5/8 x minus 3/8. Okay, it's a line, so we know that the domain will be all real numbers, and the range will be all real numbers. Same example as in before up there. Okay, all right. Now let's move on to the number 15 question. I think it's the last one on here. Okay, so the inverse, now the line's different. Line only has, its inverse function is itself. The other ones, they're going to change. So the inverse function of x cubed, x to the fourth would be the root of that. Okay. This would be negative 1 minus the outside, so it's going to be plus 1 on the inside. So what I'd have is the fourth root of x plus 1. Okay, that makes that anchor point negative 1, 0, by the way. Okay, so when I graph that, how I graph fourth root is I type the number 4, then shift, and then where the caret is, then x plus 1. And I draw it, and it looks like this. Okay. So I got negative 1, 0, infinity, infinity. So my smallest x value is negative 1. My biggest is infinity, so x is greater than or equal to negative 1. And then the y, smallest y is 0. Biggest y is infinity, so y is greater than or equal to 0. Okay? So that's the domain and range for that one for the inverse. All right? Almost done here. Getting through this. Okay? All right? Now, for x plus 4 squared minus 2, the opposite function, the inverse function, would be square root of x. The plus 4 goes to the outside, becomes minus 4. The minus 2 comes to the inside, becomes plus 2. Okay? So that would be the answer here. Okay? All right, my anchor will be negative 2, negative 4. And I can confirm that by graphing it. Square root of x plus 2 minus 4. Draw, okay? And I'd have this action, same as the other graph almost. Negative 2, negative 4. Infinity, infinity for that arrow. Smallest x is negative 2. Biggest one's infinity, so x is greater than or equal to negative 2. Oops, it's pretty sloppy. My smallest y is negative 4. Biggest y is infinity, so y is greater than or equal to negative 4. Okay, and that's the domain and range for that one. Okay. Opposite of x, square root of x, would be x squared. Minus 7 would go outside, plus 3 would come inside. So they switch locations and operations. Okay, so that would be that. Okay, we know the anchor there is going to be 3, 7. Okay, if you want to graph it and see what it looks like, that's a good idea. Alright, so I got this. That's going to be infinity, infinity. That's going to be negative infinity, positive infinity. 3, 7. Okay, so for the domain, smallest x is negative infinity. biggest is positive, so my domain is going to be all reals. My range, the smallest y value is 7, biggest is infinity, so that's why it's y is greater than or equal to 7. Okay? So that's the domain and range for that one. Okay? Last couple questions. Graph the function. Okay? What you're looking to do is come up with some points. Okay? And draw a similar graph. So the way I would look at that is here's your x, that's -2. That's -2, whoops, didn't look at that right. It's going to be -2, -2. That's going to be -1, -1. That's going to be 2, 0. So what you want to do is you want to flip that around, okay? You want to flip those around. So I know that sounds sort of confusing. I'm still going to have -2, -2. I'm still going to have -1, -1. But now I'm also going to have 0, 2. So my new graph is going to be here, here, and here. So it does this action, okay? That happen to be coincidences, but what you want to do is you want to switch the x and y, okay? On this one, you could use the point -2, 0. You could use the point 0, 2. You could use the point 1, 3. You can use the point 2, 2. Okay? All right? You could use the point 1, 2, 3, 4. 1, 2, 3, 4. You could use 4, 4. Okay? Those aren't great. Okay? But what you want to do is you want to switch around. So 0, -2. Okay? 2, 0. Okay? 1, 3. Okay? 2, 2. Okay? 4, 4. So now you got something that looks like this. Okay? If you want to continue that, you could. I'm not going to be overly picky, as long as you can show that you're switching x and y. All right? And the last problem here, hopefully I get this done before the video dies. Okay? All right, 2/3 x, says graph the function and its inverse. All right, what you want to do, use a couple values that say -1, 0, and 1. Okay, put those into your function. Your function is 2/3 x minus 1. Okay, so 2/3. All right, I'm just going to put -1 in. Let's see, what is it, +1 or -1? -1. Okay. So I get a -1.6. I get a -1. And I get a -0.3. So -1.6, -1, -0.3. So if I wanted to graph that, got this, I got this, I got this. So here's my function. Now to graph the inverse, I switch these around, so -1.6, -1, -1, 0, -0.3, 1. So -0.1.6 would be here, -1 would be here, -1, 0 would be here, -0.3, 1 would be here. So this would be my other function. Okay, so that's inverse. Okay, all right, all you're doing here with these graphs is switch x and y. Okay, when you get up with these, okay, what you want to find is you want to find the inverse function first. All right, then you want to switch locations and operations. Okay. And if you do that, you should do pretty well. Use your calculator to do domain and range and graphing.